بسم الله الرحمن الرحيم. الإخوة المفكرون والأدباء، الإخوة والأخوات، بناتي الطالبات، أحييكم بأطيب التحية وأرحب بكم في ندوة إسهامات ابن الهيثم بالحضارة الإسلامية، حيث نلتقي اليوم بحضرة الثقافة والأدب والعلم على هامش معرض الدوحة الدولي السادس والعشرون للكتاب، بمشاركة الأستاذة الدكتورة عائشة المناعى والسيد ألبرت سميث والسيد مايكل هامilton، لمناقشة أبرز إسهامات ابن الهيثم وأثرها في منارة الحضارة الإسلامية، حيث يرجع الدارسون إلى علماء المسلمين ومنهم ابن الهيثم الفضل في منظور أساليب البحث العلمي، فهم الذين وضعوا أصول المنهج العلمي الحديث. وسوف يتناول محاضرون اليوم الكشف عن مآثر هذا العالم الفذ ودوره البارز في إسهامات الحضارة الإسلامية وإنجازاته المميزة، والدعوة لإحياء ذكرى علماء المسلمين الذين خدموا الإنسانية وأضافوا إلى ثروتها العلمية إضافة هامة. وبما أن اليوم نلتقي لنسلط الضوء على إسهامات ابن الهيثم، جدير بنا أن نستعرض لكم مقتطفات بسيطة من سيرة حياة ابن الهيثم، وهو أبو العلي الحسن ابن الهيثم من أصل عربي، عالم موسوعي من أعظم علماء الرياضيات والفيزياء، وهو مؤسس علم البصريات. ولد في البصرة عام 354 هجري 965 ميلادي، وعاش في حياته الأولى وكان في طفولته عازفا عن اللهو مع أقرانه، مقبلا على القراءة والاطلاع. سافر في طلب العلم فذهب إلى بغداد والشام ومصر، وتنقل بين أرجاء الأقطار الإسلامية. ونستهل ندوتنا مع الأستاذة الدكتورة عائشة المناعى، وهي غنية عن التعريف، عميدة الدراسات الإسلامية في جامعة حمد بن خليفة، حاصلة على درجة الدكتوراه في العقيدة والفلسفة الإسلامية من جامعة الأزهر، وعضو البرلمان العربي الانتقالي. لها العديد من البحوثات والدراسات المنشورة، وتعد من الشخصيات الأكاديمية البارزة في مجال الدراسات الإسلامية، ولها باع طويل في نشر الفكر الإسلامي الوسطي في المجتمع، ولها العديد من المؤلفات والأبحاث الدينية. فلتتفضل الدكتورة عائشة بإلقاء كلمتها مشكورة.
شكرا جزيلا دكتور. بسم الله الرحمن الرحيم، وصلاتي وسلامي على سيدي ومولاي محمد بن عبد الله وعلى آله وصحبه أجمعين. محمد صلى الله عليه وسلم صاحب الحضارة والداعي لها والمؤطر لمكوناتها وأخلاقياتها. شكرا للأستاذ الدكتور مايكل هامilton، مؤسس ورئيس منظمة أسس جديدة للسلام، وهو مؤلف كتاب العلوم العربية رحلة الإبداع، ألفه لمؤسسة قطر في افتتاح واحة العلوم. وشكرا للأستاذ الدكتور مركز سميث الذي ألف الكثير عن ابن الهيثم. وشكرا لمدير جلستنا، جزاه الله خير على إدارة هذه الجلسة، وجزاه الله خير على استقطاب هؤلاء البنيات العزيزات، طبعا الذين سيثرون إن شاء الله هذه الجلسة بحضورهم، وأيضا نتمنى المناقشة أيضا إن شاء الله. وشكرا لكم جميعا. نعلم أن في الحضارة أو كلمة الحضارة في أي مفهوم وفي أي لغة من اللغات لا يخرج عن إطار المكان والزمان والإنسان بفكره ورؤيته، وأن المعرفة هي الأصل الجامع للتحضر في كل صوره وأشكاله. ومن هنا ما هي المشكلة؟ السماعة. وأن المعرفة هي الأصل الجامع للتحضر في كل صوره وأشكاله. ومن هنا كان الإسلام في مبدأ نزوله يتصدر فيه القرآن الكريم أمر الله سبحانه وتعالى لرسوله صلى الله عليه وسلم بكلمة اقرأ. اقرأ باسم ربك الذي خلق، خلق الإنسان من علق، اقرأ وربك الأكرم الذي علم بالقلم، علم الإنسان ما لم يعلم. ويخبره بأن الله هو من علم بالقلم. ولذلك حينما يريد المسلم وأي منا يعني نحن كمسلمين أن نصف أنفسنا بالتحضر نقول نحن أمة اقرأ. طبعا سواء يعني كنا احنا صادقين في هذه الكلمة أو في هذه الجملة، ولكن نمارسها أو لا نمارسها هذا أمر آخر. إنما نحن أمة اقرأ. وطبعا كلنا نعلم مفهوم كلمة اقرأ ماذا تعني، وكلمة القلم ماذا تعني. تعني العلم، تعني التحضر بصفة عامة، يعني ما في كلام. في الدقائق المعدودة لي أيها الأخوة سأتحدث بإيجاز شديد عن تلك الشخصية الإسلامية. طبعا أنا لست متخصصة في هذه الشخصية، ولكني لأني أدير مركز محمد بن حمد لإسهامات المسلمين في الحضارة، ولي اهتمام شديد بعلماء المسلمين ومن ضمنهم طبعا الحسن بن الهيثم. ونحن عقدنا يعني في المركز ندوة في 2013 عملناها عن الحسن بن الهيثم. والآن بصدد أننا يعني نترجم، لأن يعني من جزء من عمل المركز ترجمة أمهات الكتب القديمة إلى اللغات الأخرى، سواء بالإنجليزي أو بالفرنسي أو بالألماني، يعني بأي لغة من تلك اللغات. هذه الشخصية الإسلامية استلهمت تلك المقولة فأبدعت في الحضارة وللحضارة، وهو العالم الموسوعي الحسن بن الحسين بن الهيثم، المولود 354 هجري وتوفي 430 هجري، يعني في 965 ميلادي مولده، ووفاته في 1038 ميلادي. حينما أصفه بالموسوعية فهذا أمر صحيح، لأنه برع في الهندسة والفلك والرياضيات والطب، أي أنه جمع بين علم الطبيعة وعلم الأخلاق وعلم النفس، وهو في كل ذلك يجعل مرجعه الدين في مصدريه الكتاب والسنة. وقد وصفه المؤرخون بكثير من الأوصاف، منها أمير النور لبراعته في مجال البصريات. وعندما قال مدير الجلسة البصريات وبعد ذلك قال الحسن مولود في البصرة، قد يفهم منا أن بصريات تعود إلى البصرة. لا، هي البصريات المقصود بها الرؤية البصرية العينية، يعني برع في مجال البصريات والفيزياء. وقد احتفلت اليونسكو في هذا العام 2015 بمناسبة أن أطلقت عليها العام الدولي للضوء وتطبيقاته، وجعلت الحسن بن الهيثم هو النموذج الممثل لهذا العلم. ولاعترافنا نحن بأهمية هذه الشخصية العبقرية في تاريخ الإسلام، كما قلت عقدنا ندوة سابقا قبل اليونسكو يعني، وأيضا سنترجم له كتاب حققه الأستاذ الدكتور أحمد فؤاد باشا، وهو أستاذ الفيزياء المعروف في جامعة القاهرة. وهو يعني يتحدث عن الضوء والمكان، أو الضوء والأضواء في المكان، ويتحدث يعني حديث رجل عالم هو حققه الدكتور أحمد فؤاد باشا، ونحن إن شاء الله سنترجم رسائل ابن الهيثم عن المكان والضوء وأضواء الكواكب إلى اللغتين الإنجليزية والفرنسية. نحن نعلم بأن بأن علماؤنا القدماء، ومنهم طبعا منهم ابن الهيثم أو الحسن ابن الهيثم، قد يؤثرون وقد يتأثرون. وهذا أمر طبيعي جدا في المجتمعات، في البشر يعني بصفة عامة. لا يمكن أن يكون هناك بشر أو مجموعة من البشر يعيشون على هذه الأرض لم يتأثروا أو يؤثروا. طبيعي يعني التأثير والتأثر أمر طبيعي جدا. ولذلك أنا من وجهة نظري حقيقة أن ليس بعيب أن يكون هناك أن يتأثر شخص، أن يتأثر مجتمع بمؤثر آخر، بشخص آخر، بمجتمع آخر، ليس عيبا أبدا على الإطلاق، لأني كما قلت هذا أمر طبيعي. فلذلك عندما نقول أن مثلا في العلماء الغرب تأثروا بالهيثم، لا إشكال، يعني هذا لا يغض من حقهم ولا من قدرتهم ولا من علمهم، لكن الحقائق تذكر، لابد أن الحقائق تذكر. البشر في أفكارهم وعقائدهم وعاداتهم وتقاليدهم كلها يتأثرون ويؤثرون. ولذلك حينما يثبت المؤرخون تميز ابن الهيثم في علمه وتأثر الآخرين من علماء الغرب أو الشرق به، فذلك وإن كان سبقا لابن الهيثم إلا أنه لا يخل بعلم من تأثر به. وهذا ما أثبته الكاتب الأمريكي ريتشارد باورز في مقال له أحسن فكرة شهدتها الألفية الماضية، ويقصد بذلك فكرة الحسن بن الهيثم الذي حل مشكلة أو معضلة الضوء والإبصار من خلال منهج علمي سليم. هذه الفكرة كانت هي الدليل إلى أكثر الأفكار العلمية والتقنية، وهي أول ثورة علمية أساسية في تاريخ البشرية، ويرجع إليها كل ما حدث بعد ذلك من اكتشافات وثورات علمية على أيدي جاليليو وماكسويل ونيوتن وأينشتاين وغيرهم. ويرى الباحثون أن كتاب المناظر لابن الهيثم قد شكل ثورة في علم البصريات، وقد قدم فيه نظريات جديدة في علم الضوء، وقد تأثر علماء أوروبا بهذا العلم بعد ترجمته، وبذلك قد أثر ابن الهيثم في كل الذين كتبوا في البصريات من بعده. وعلى ذلك فابن الهيثم يعد واحدا من علماء المسلمين الذين يمتد أثرهم إلى الآن في العلم الحديث، وساهموا في بناء الأسس والمنهج العلمي القائم على الاستقراء والتمثيل والتجربة والقياس والاستنباط. وطبعا نحن عندما نمتدح عالم يعني له باع في البحث العلمي بهذه الصورة، يعني أمر حقيقي ونحن صادقون فيه. لماذا؟ لأن الآلات والأدوات التي تستخدم الآن الحديثة غير موجودة في السابق، فكيف يستخدم التجربة والبرهان والقياس وكل هذه الأمور، الاستقراء وكل هذه الأمور، التجربة العلمية وخاصة في الماديات يعني. لا يفوتني أن أذكر بأن الحسن بن الهيثم قد ساق كل علمه معتمدا على إيمانه العميق يعني بالله سبحانه وتعالى ووحدانيته، ومعتمدا على الأخلاق والقيم الإسلامية التي يذكرها كثيرا في حديثه عن العلم وعن السعادة. طبعا هو كتب في كثير من الأمور، كتب في الفلسفة أيضا وتحدث فيها عن السعادة. ومنبع السعادة والعلم من الفكر الصحيح كما يقول، الذي يتميز به الإنسان، ويرى أن تلك السعادة معناها إدراك الخير على الحقيقة، ذلك الخير الذي يصفه بأنه لذة العلم بكل حق والعمل بكل نافع. يعني كأن أجمل كل الأخلاقيات في هاتين الكلمتين، وهما عنصرا الحكمة التي تسعد الإنسان، وبهما تكتمل إنسانية الإنسان، حيث أنه بهما بالحق يعني بالعلم النافع يتشبه الإنسان في أفعاله بالله تعالى. وقد أراه أنا في ذلك يشير إلى حديث الرسول صلى الله عليه وسلم عندما يقول تشبهوا بأخلاق الله. والتشبه بأخلاق الله هذا الكلام فيه قصة طويلة وكثيرة، ولكن لا أستطيع طبعا أن أتحدث فيها الآن. إذن هذه إشارات أنا بسيطة أقولها لكم، ولكني لا أستطيع أن أفي يعني بالموضوع بصورة عامة. أذكرها عن حسن بن الهيثم العالم الموسوعي، وأتمنى أن أسمع ونسمع جميعا من أخوي الدكتور مارك سميث والدكتور مايكل هاملتون أعمق من تلك الإشارات التي يعني قدمتها لكم، وأن ينير الله سبحانه وتعالى دربنا بنوره الذي يملأ السماوات والأرض. الله نور السماوات والأرض، مثل نوره كمشكاة فيها مصباح، المصباح في زجاجة، الزجاجة كأنها كوكب دري يوقد من شجرة مباركة زيتونة لا شرقية ولا غربية، يكاد زيتها يضيء ولو لم تمسسه نار، نور على نور، يهدي الله لنوره من يشاء. نتمنى من الله سبحانه وتعالى أن ينور دروبنا، وأشكر لكم جميعا استماعكم، والسلام عليكم ورحمة الله وبركاته.
ورقة مثرية أضافت لجمهورنا بلا شك. والآن نقف مع ثاني محاضرينا الأستاذ الدكتور مارك سميث، أستاذ تاريخ متميز بجامعة ميزوري بكولومبيا بالولايات المتحدة الأمريكية، يحمل أعلى وسام أكاديمي مرموق يمنحه مجلس أمناء الجامعة. درس في العديد من الجامعات المرموقة بفرنسا وإنجلترا، ينصب اهتمامه على تاريخ العصور الوسطى وتاريخ العلماء والنقلات الحضارية. من أهم مؤلفاته من النظر إلى الضوء، الحسن وانكسار الضوء، نظرية الحسن والإدراك المرئي. فليتفضل الدكتور البرت بإلقاء كلمته مشكورا.
Thank you for having me here. Thank you all for coming. I'm going to have to abbreviate my thing considerably. I have a lot of slides. I'm just going to rush through them, and I won't even describe. I'll try to get what I think of the high points. I've picked this topic, his discussion of the moon illusion, for two reasons. First, because I think it requires no technical expertise to understand or appreciate, and the second reason is because it exemplifies the ingenuity with which Ibn al-Haytham assimilated, built on, and eventually transcended its sources. The moon illusion, for those of you who don't know, is the appearance of the moon when it's high in the night or evening sky. It looks fairly small, but you've all probably noticed that when it gets toward the horizon, sometimes it looks really large. The question is, why does this happen? The standard answer at the time of Ptolemy, one of his major sources who lived around 160 CE, was that it was magnification through vapors, the way things look enlarged when you see them underwater. Ibn al-Haytham had a different position, and I'll talk about that. It depended on his theory of size and distance perception, and it's a very brilliant theory. By the way, the moon can actually be shrunken, as you can see here, when it refracts through the atmosphere. Let me see, where do I go? Ptolemy's theory of vision. Ptolemy believed that the eye emits rays of sort of light out to objects like this red line. Those rays then bring back the visual impression of color that comes back. It goes into the eye, through the eye, into the brain, and that's where we do all the perceptual and intellectual processes. So that when it hits a horse, it sends kind of a picture of a horse into our heads, and intellectually, perceptually, we look at it, examine it, and realize it's a horse and not, say, a mule or an ox. Ibn al-Haytham had an entirely different theory. It's not entirely, oh, by the way, for distance perception. Ptolemy believed that we could tell distance by an innate sense of our ray, these rays that we send out, how long they are, so that in this one, for example, object B will look twice as far away as object A because the ray is twice as long, and we can feel that, just the way we can feel how far away things are by extending our fingers and arms. Ibn al-Haytham had, size perception is due to the angle. So when these two objects that are equidistant from the eye subtend different visual angles. The one that subtends the larger one will look larger, that is B. But if these two objects subtend the same visual angle, nonetheless B will look larger because it's twice as far away. So you have to correlate distance with size or perceived size. This is a model of his eye. I'm not going to go through all the details. He believes that every point on an object sends rays at every spot on the object. One of those rays and only one strikes the eye along the perpendicular and hits the lens on the perpendicular. And that ray makes a visual impression on the lens. The lens then sees it, gets a visual impression, a whole slew of these rays, and then they go, into the, through the optic nerve into the brain where they're processed. All of these rays make a pinpoint impression, and I'm using this as an example, a painting by Georges Seurat, pointless painting, as you can see by the lower inset, that's kind of what's done on our lens. It's a kind of a pointless mosaic. Yeah, I'm trying to get through this. So he has an experiment to talk about distance perception and to show that Ptolemy's wrong. Distance perception has nothing to do with the length of our rays. Here's the experiment. Pretend this is a room in which two walls B and C are stood upright, so that if we see it from the side or from the top, it would look like this. From the side, it would look like this. Bore a small window or hole. Put your eye at A so that all you can see is the two walls, but you can't see the sides, the top, the ceiling, or the floor. In that case, he argues, and quite correctly, I think, that this is what you would see. You would not see wall C behind wall B at all. You would see them as if they were together, contiguous to one another. So what he's saying is that you need contextual clues. You can't do it by ray length alone. Here's an example that these two poles, there's no way of telling from this particular context how they relate to one another spatially, but as soon as we put them in the proper spatial context, you can see that one is behind the other, and there's a whole lot of spatial clues in this that tell us. And we can tell distance from this because of all of these clues. Whereas if you have an undifferentiated spatial system like this, it's impossible really to tell how far away things are. He was aware of that. Now, let me go back to this Seurat painting. The problem with this is there's no depth in it. It's a two-dimensional array. So how is it that we can tell distance? For example, on this one, I'm pretty clear that this is about 5 meters, maybe a little bit less. This is about 20 meters. This is about 30 meters. Now, I may have the numbers. You may not agree with the numbers, but you can see in the relative order. In other words, we can distinguish distance in this, and yet there's no depth to it. So how do we do that? Well, obviously we do it through spatial clues. I won't go through this thing, or I will very fast. And one of the key spatial clues here is comparing this woman to, in the middle, to the couple to her right. I can judge just by sort of simple measurement that she's about 2.5 times as large as they are, as the couple in back. And I can judge the distances from that. But here's the thing. Nonetheless, I know that the couple in the back are just about the same height as she is. Now, how do I know that? Well, I know that from spatial clues, all the spatial clues that I've got in this painting. One last example. This is a desert scene from Colorado in the United States. A lot of spatial clues in this too, and even though Haytham is well aware of these kinds of spatial clues. So if I look at these stones here in the foreground, I can sort of guess that the biggest one of them is around 10 centimeters in cross-section. When I've got that in mind, then I can figure that this distance is probably around 10 meters, maybe just a little bit less. Then I happen to know that these are pinon trees, which are specific to that desert. And on my knowledge of that, then I know this is around 2 meters tall. Therefore, I can guess that this is around 60 meters. Then, unfortunately, I don't have many clues along the way here, but I can guess that these mountains, I can guess that these mountains are maybe 5 kilometers away. I can be quite wrong in that because I don't have those spatial clues. So in order to do spatial perception for Haytham, you have to have markers along the way. And you do that by size and distance perception in a rather complex model. The upshot of that is this. If we put this circle here, and we put it in the foreground, then it looks to be around 60 centimeters in diameter, according to the, too loud? Too soft? Okay, it looks to be around 60 centimeters in diameter, according to the, the measure that I did of the rocks. Now, if we send it back across the road, about 10 meters away, you'll immediately see, if I've told you it's 10 meters away, it looks much larger. I hope you can all see that. If I send it 5 or more kilometers away behind the mountains in the background, then suddenly it looks huge. And yet all this time it's exactly the same size, it subtends exactly the same visual angle. This is what Ibn al-Haytham really realized, and this was the key. Going to theories of why the moon and sun look larger at the horizon, this is the one theory I was talking about, that somehow it's because it goes through thick vapor that it looks magnified the way things will look magnified through water. Ibn al-Haytham believed that, he bought that, but he also realized that if that were the case, the amount of refraction that would occur, the amount of magnification that would occur on the basis of simple vapors would be so minimal that it could not possibly account for how large the moon appears. So he had to look for another reason, and he looked to the psychology of perception and actually misperception of distance and size. So here's his theory. In his day of cosmology, he believed that the heavens were a sphere, the Earth was at the center, it was tiny compared to the sphere. In fact, the sphere was about 108, by his calculations of his day, it was 118 million kilometers away, which is a lot, but nothing like what we think today. The point is that it's so far away, and there's no trees, there's no spaces of ground, there's no mountains to give any spatial perspective to it, that we simply cannot perceive its concavity. It's just too far away, it's too, we can't see anything spatial, none of its spatial dimensions. All we can see is its blueness in day and its star-studded blackness at night. That's all we can see. As a consequence, according to Ibn al-Haytham, instead of seeing the heavenly vault as a sphere overhead or a dome, we see it as a high flat ceiling parallel to the ground we stand on. And of course that's aided and abetted by cloud formations like this that look like, they're actually along the contour of the sky, this flat ceiling-like sky. So when the moon or the sun goes from zenith overhead towards horizon, it should, if it really were a flat ceiling, it should look something like this. I'm using this as a kind of an analog. A set of the same size light fixtures down a long ceiling. And you can see how they get smaller and smaller and smaller, and they subtend smaller and smaller distances. So if the sky were like that, then this is what it would look like. As the moon headed toward the horizon, this is what it ought to look like. And so what you eventually get is that same pattern that I showed. And yet that's not what happens. Why? Well, according to Ibn al-Haytham, here's what happens. If we're standing on the Earth, our feet planted at the point where the horizon plane meets the Earth. We're looking up at the moon. The gray lines subtending the moon, that's the visual angle. The actual orbit of the moon is the circular arc that I've got there. But the apparent orbit along the ceiling of the sky is that light gray line. So when the moon moves through horizon, as you can see happens here, the perceived moon on that horizon, that ceiling line, looks as though it's getting bigger and bigger because we are correlating its estimated apparent distance to the angle that it subtends, the visual angle it subtends. It subtends the same visual angle, but it looks as though it's farther away, so it looks bigger and bigger and bigger to us. So, as a consequence, what happens is that when the moon is up here, it seems to be a fairly small size, but then because we've seen it go along that ceiling, when it gets down here, it looks as though it's gotten bigger, even though and we know it subtends the same visual angle. I've probably run out like 15 minutes. So the only point I want to make is that this is based on, by the way, this is a theory that held sway. It was pretty standard up until fairly recent times, up until the 18th, 19th centuries. with some variations, is a brilliant theory, actually. Unfortunately, by modern psychology, it's not really quite right, but that's neither here nor there. It nonetheless, was an important sort of addition to the effort to make sense of the moon illusion. But more important is its dependence on a really brilliant, for today particularly, innovative theory of size and distance perception, primarily, by the way, on the basis of bodily units, that has all kinds of philosophical implications that don't really come to fruition until, well, really the 18th century, the early 18th and late 17th century. So that's it. Thank you.
شكرا للأستاذ الدكتور ألبرت. ما قدمه لنا إثراء لثقافتنا ومعرفتنا حول الحضارة الإسلامية وإسهاماتها. نشكره على الورقة التي قدمها. Thank you very much. والآن يشارك معنا الأستاذ الدكتور مايكل هاميلتون. هو دبلوماسي سابق ومؤسس ورئيس منظمة أسس جديدة للسلام، وعلاوة على ذلك هو باحث سياسي مؤثر وكاتب وروائي أمريكي ذائع الصيت، واكتسب شهرة واسعة من خلال كتابه تاريخ ضائع والعرب، بحث في العصور الذهبية، حيث يعد هذا الكتاب محاولة لإلقاء الضوء على الفترات الزاهرة في العصر التاريخ الإسلامي، ونال العديد من الأوسمة والجوائز. فليتفضل بإلقاء كلمته دكتور مايكل بالكامل.
Can everybody hear me? Is this microphone? Salam alaikum. It's always an honor and a pleasure for me to come to Doha and Qatar. This is probably my 8th trip, but I haven't been here in 5 years. And each time I come, it's bigger, and there's more going on, more people, and so I'm very proud for what you're doing as Qataris. Tonight, I should make clear that I am a different kind of scholar and writer from my esteemed colleague, Dr. Smith, and Dr. Aisha, even I believe, and that is because I believe my job is to take their hard work, their hard research, and bring it to a mass audience. And my primary audience is an American, a European, an Asian audience that does not understand Muslim civilization and history. The reason I do this is because there are those who are trying to divide us and are trying to exploit conflict and difficulty for their own ends. I'm a pacifist, I guess you could say. I believe in peace. I believe in difference. I believe we're obviously different. We dress differently. We speak a different language. We may have a different religion. We like different food. But we're all human beings. And we all live on this planet that Ibn al-Haytham helped us understand in terms of optics and the shape and structure of the universe and how we see it and evaluate it. So I take their hard work and try and translate it into something that the average person can understand. And the objective is so we can find a way to all inhabit this planet together in a peaceful way. I wrote this book, Lost History, 8 years ago. It was translated into Arabic, into Indonesian, into Urdu, into Japanese, Korean, and other languages. So it went around the world. I hope to bring the message to a wider audience through film and television, but that's harder. It costs more money. But my main argument, when I take someone like Ibn al-Haytham or Muhammad al-Khwarizmi and these other great scholars from Muslim history and civilization, there is no clash of civilizations. We all live in the same global civilization now. It centers around things like this that couldn't exist without the discoveries of Ibn al-Haytham and al-Khwarizmi and others. We as Westerners do not acknowledge what we owe to your ancestors for their discoveries and inventions. I believe, to be honest and to understand the world, we need to do that. Why was your ancestral culture so inventive and great? Because of the early values of openness and tolerance. I believe that if we don't know our past, how can we meet the future? We can't even understand the present. We have misunderstanding on both sides. The mainstream Western narrative of Islam is critical. In my country, the height of Islamophobia is higher than anything I've seen in my lifetime. It goes back 1,300 years. And all that's being talked about now is conflict and difference. Meanwhile, in the Muslim world, a lot of young people don't know about the lost legacy of intellect, invention, and tolerance. We talk about bravery and piety, but we need to find the full story so we can all work together. As I said, I reject the clash. I'm trying to help us understand each other, understand the real differences that we have, and look for connections and commonalities, trying to recover our lost history and thereby build a better future. I believe that Arabs and Muslims helped create the world's most inventive force from the years 750 until 1500. That's a long time. That's 800 years when this culture and civilization were the centers of world invention and innovation. Why? Because a culture of intellect that goes back to the Prophet himself, questioning assumptions like even al-Haytham did when he rejected Ptolemy's theory of light. Ptolemy had said, as the professor said, a ray came out of your eye and struck the object, and he did real hard scientific investigation and proved that that was not correct. There's also a tradition from early Islam of assimilation and tolerance, and then of leadership and philanthropy. And these areas where early Muslims, Arabs, Persians, Africans, Indians, and so on worked were in mathematics, astronomy, chemistry, medicine, architecture, literature, and then this quality of leadership. I write a lot in my book about the forgotten legacy of Baghdad. Today, Baghdad has become a place of tragedy and pain that goes back some decades, but from the time of the Abbasids until the invasion of Hulagu Khan in 1258, the Mongols, Baghdad was the center of the world, in my view. Thanks to great thinkers, rulers like Harun al-Rashid, his son al-Mamun, who had a dream of Aristotle telling him that God could be known through reason, through hard intellectual investigation. The Mutazilites, a group that doesn't exist anymore, was an Islamic group that believed in reason and rationality. He was, of course, in conflict with Ibn Hanbal, the founder of the current Hanbali school of Islam. But Baghdad was not the only place. Cairo, where Ibn al-Haytham did his hard work, thanks to the patronage of the Fatimid leadership of al-Hakim, and then the patronage of his sister, Sitt al-Mulk, who was considered, I think in her day, the wealthiest woman in the world. Founder of Al-Azhar University, the House of Knowledge. But not only Cairo and Baghdad, also Damascus and Cordoba and Aleppo and Isfahan and so many other places in the Muslim world. Mathematics. We Westerners are always thanking the Greeks and the Romans for our intellectual heritage, and they certainly did a lot. But Greek geometry doesn't make this work. Algebra, algorithms, trigonometry are what define this digital device. Where does that come from? Well, it comes from the Arab Muslim world. It came originally from the desire to know which way Mecca was, so people could know how, in what direction to pray, and that involved stars and all sorts of triangulation. But then other things like music, science, and philosophy. 1,000 years ago, Islamic scholars didn't divide things up into disciplines the way we do today. They were holistic thinkers. It was all part of the same study of trying to understand this creation that we live in. It's very much like what we now call in the West complexity theory, when they try to find the commonalities between these separate disciplines. Here's the father of the algorithm. In fact, the Western word algorithm comes from his name. His name was Al-Khwarizmi, and the Latin, the Greeks, took his name and they westernized it into algorithmi, and then the mathematical formula that he invented became the algorithm. This man, he took Indian work from Brahmagupta. This was in the time of Al-Mamun in Baghdad, and he took that, he rediscovered the concept of the zero, and he also found this system of writing numbers that we now call the Arabic numerals, the numbers that we use in the West and that you use. They actually came from India, but Al-Khwarizmi rediscovered them and universalized them for the world. He also came up with the method of finding lost quantities, algebra, reckoning, which is algebra. He also may have been the first to take mathematical theory and try and express it in artistic expression in what later evolved into the beautiful designs of the Arab Muslim world. I would say that Al-Khwarizmi had more impact on our world than Albert Einstein. And that's not because Albert Einstein isn't a genius, it's because it's hard for the average person to even understand the theory of relativity, whereas average thinkers like me can do algebra to some point and maybe even start to play around with algorithms. And since his work defines all of this, I give him more credit. If we had intellectual property concepts in that day, his discoveries would probably be worth about $100 trillion. And here, the guy that we've been talking about tonight. I don't want to spend a lot of time here because I have an expert sitting next to me and I don't want to get an F in my history class. But one of his key discoveries, of course, he was busy questioning Ptolemy. And unfortunately, the Greeks were great theorists, but they didn't experiment to verify their theories. They sat and dreamed up wonderful things, as did Aristotle and all of them. But the Arabs and the Persians working in the great Muslim centers actually began to implement the modern scientific method of testing hypotheses against reality. One of his key discoveries was, when Ptolemy had the Earth at the center of the universe, trying to explain the motions of the stars and planets across the sky was really hard to do. So he came up with this very complicated thing called the equine. And Ibn al-Haytham looked at that really hard and he said, I think there's something wrong here. Well, there was something seriously wrong because the Earth was not at the center of the universe. How did they impact on us? Well, as I said, their work enables software, computation, mobile devices, data mining, Google, financial market modeling, which isn't always perfect, I must say, if you lose money in the stock market, genomics, medicine, chemistry, engineering, travel to the moon, travel of the recent spacecraft to Pluto. This is all dependent on Arab Muslim discoveries. It's the basis of our modern global civilization. Now, I don't know how much time we have. How much more time should I have? 5 minutes, okay. Well, science and engineering, this is obvious. Empirical science, chemistry, and all that has its roots in this part of the world. Here's a guy, another one of my saints from Muslim intellectual history, and that is Jabir. He's called a chemist or an alchemist. Actually, in the early formation of that word, it means the same thing. In the West, it came to have a connotation of magic. But in fact, it really came from the word alchemy, which has the same thing. He's the father of modern chemistry, I believe. He worked in Baghdad under the patronage of the Abbasid caliphs. He was trying all sorts of far-out ideas that we're still trying to do today. He tried to create artificial life. It was a mystical project called Takwin, which was somewhat heretical. It got him in trouble with the religious authorities, but that shows how far his mind was going. He was a brilliant man. He also made practical discoveries like the alembic, which is a still, which some people use to make illegal whiskey, but also used for other chemical processes. He discovered nitric and hydrochloric citric acids. He made ethanol from boiling wine. He enabled rust proofing, hair dyes, flame retardant chemicals, fluorescent ink. Medicine. There's so much here, we could go on for 5 hours. But in the Islamic world of 1,200 years ago, whereas Western Christianity was all obsessed with sin and judgment, and if I'm sick, it's because God is punishing me because I did something bad, because of the statements of the prophet and later discoveries by those who followed him, they didn't have that connotation of sin. It was a problem, a physical problem to be solved. So how do we figure this out and fix it? And he had made statements himself about personal hygiene, about public health, about quarantine to prevent spread of disease, and so on. This all led to the rise of modern hospitals, pharmacies, even insane asylums where people were treated mercifully and in a humanitarian way, whereas in the West, if you had a mental problem, they thought the devil was in you and you had to be pushed away or maybe even killed. Surgery, obstetrics, orthodontia. Here's another saint of Muslim history and discovery, Al-Sarawi, working in Al-Andalus, which is now Spain. His discoveries had deep influence on Western Europe for 300, 400, 500 years afterwards. He invented things like the obstetric forceps for birth, plastic surgery, kidney stone treatment. He described hemophilia. He had some actual therapeutics for heart disease. He did the first suturing, as far as we know, to close wounds, modern orthodontia for fixing teeth, and he invented about 200 medical instruments. I'm coming up close to the end, I think, but I'll close with another forgotten medical genius in Cairo, Al-Nafis. He was originally from Damascus, but he went to work in Cairo. Apparently, he was the first to describe the circulation of the blood from the heart to the lungs and back again. He rejected a very great Greek thinker, Galen, who said that the blood passed through a membrane in the heart. That's how it went from the left to the right side of the heart. But Al-Nafis showed how it circulated through the body. It took 300 years for those ideas to make it into Europe, but when they did, they were credited to William Harvey in England, which, well, whether he saw what Al-Nafis had done 300 years before, we'll never know. It seems like he had heard of these ideas indirectly. So at that point, I will conclude, and I hope we do have time for questions.
Just 1 minute.
Okay, 1 more minute? I'm going to keep going, all right. Architecture, well, we know this building. Right now, there's a lot of controversy in that area between the Palestinians and Israelis, but that is the Dome of the Rock. That's the oldest surviving example of Islamic architecture done under the Umayyad caliphs based in Damascus. But there's so many other beautiful expressions of this tradition. We have Madinat al-Zahra in Al-Andalus, which doesn't exist anymore because after the Christians retook Spain in 1492, they took all the stones from Madinat al-Zahra and used it to build cathedrals. Well, that's what happens. People do things like that, but it was the greatest city in Europe until probably 1200. And of course, beautiful the Alhambra in Granada, Isfahan, magnificent architecture, Bukhara in Central Asia, and of course the Taj Mahal. And then finally, I think I'll stop here.
Thank you.
I'll stop there.
Thank you. ما قدمه له ثقافتنا ومعرفتنا حول الحضارة الإسلامية نشكره على الورقة التي قدمها. الآن نفتح باب النقاش وطرح التساؤلات من الحضور الكرام في حدود 10 دقائق فقط. تفضلوا. إذا حد عنده أي مداخلة إضافات. تفضل. اسمك و عرف نفسك لو سمحت.
Okash Al-Dari, Professor of Psychology. I'm very grateful for the two speakers and for the very fine introductions from Professor Munari. The two things are missing quite often from our debate when we discuss the contributions of Muslim scientists or of scientists under Islamic civilization. One is that we always say that they have picked this up from the Greek sources, and even those specialists in the history of science always go back to the Greek sources. What is quite remarkable is many of the Greek scientists themselves learned this in the University of Alexandria and in Heliopolis, and they give a great deal of credit to ancient Egyptian and the ancient Mesopotamian and the ancient Syrians. So the ancient Near East in general should really be brought back as the origin of all these great scientific contributions, which then became the source for the Greek and Romans. So this is the first point I wanted to make. The second point is we are quite keen on pointing out the scientific contributions in medicine, chemistry, engineering, etc., etc. Less so on humanities, or a great deal of thinking going on in Miskawi, Tahdhib al-Akhlaq, or Farabi, all these great thinkers in humanities. And as you pointed out, the holistic approach was the standard and norm of the day. And I think we should highlight also the contributions of Muslim scholars, or of scholars under Islamic civilization, because many of them were actually Muslims, but they're quite happy to contribute, just like the Muslim brothers and sisters. Thank you.
Thank you. من بعد؟
دكتور فين؟
تفضل. عرف نفسك لو سمحت.
Assalamu alaikum, good evening. Thank you very much for a very enlightening presentation. I have a sort of suggestion and questions. We as Muslims, we have been knowing and all this contribution. Now the question is for the new generation, how to embed or incorporate this to the further younger generation, because we are taught in the textbook, for example, William Harvey circulation of blood first discovered by this guy. But in reality, it is a different fact. So how to embed? This is a challenge, okay? It's in the Western world or even our own the Asian and the Middle Eastern world, that we are not teaching this to the kids, how to embed and how to incorporate into the textbook. It has to be top-down approach or the bottom-up approach. So this is a challenge, and I would like you to share how to do that. And some of the authorities sitting here, maybe they can share our light. Thank you very much.
Thank you. من بعد؟ تفضل. عرف نفسك لو سمحت. سماعة وين الميكروفون؟
بسم الله الرحمن الرحيم. الدكتور عبد الحكيم سيف الدين، أستاذ التاريخ الإسلامي المشارك في كلية في قسم العلوم الإنساني جامعة قطر. الشكر الجزيل لمنظمي هذه الندوة وللعواقب التي قدمت، والشكر الجزيل أيضا لمن أشاد أيضا بدور العلماء المسلمين في تشييد الحضارة الإنسانية، لا سيما علماء العلوم الطبيعية ذكروا اليوم في هذه الحالة المداخلة. لكن السؤال الذي يمكن نطرحه صحيح في الأوساط العلمية في الغرب أو في أوروبا يمكن يعرف دور هؤلاء، لكن هل يعرف إسهامات أو تعرف إسهامات هؤلاء العلماء المسلمين الذين قدموا عصارة خبراتهم يعني أخذوا العلوم من اليونان لكنهم أضافوا إضافات كبيرة جدا وكبيرة، وأيضا قامت على هذه العلوم والنهضة العلمية الحديثة في أوروبا. هل على المستوى الشعبي وعلى المستوى أيضا المناهج الدراسية في الغرب هل هذا معروف وموجود، خصوصا في ظل الصورة النمطية الموجودة في الغرب عن العالم الإسلامي وعن الإسلام؟ شكرا.
في حد؟ خلاص؟ تفضل يا مايك.
Thank you so much for the speakers, all of you on this podium. And I just want to ask a question for the director. He pointed out two main things as the key reason for the human or for the thinking in general and for the Muslim contribution to civilization according to these two basic things. And he pointed out tolerance and openness. Tolerance and openness as the main factors behind all these openness and holistic approaches. So I just want to again re-question whether these two things, if they are adopted by Muslims of today, will it be the same factor for development or not?
Okay, shukran. خلاص؟ Okay, each one 3 minutes. Okay, تفضل دكتور. آخر سؤال. عارف نفسك.
Right, okay. My name is Dr. Abu Shar. I'm the associate professor of Islamic history at Qatar University. I've got actually a very, very small and short question regarding. Sorry, actually, I've missed most of the talks except the last one, and I've learned a lot from that one. I've got actually a very short question. Muslims have been doing very well for a number of centuries. My question: what went well? So why all these kind of contributions to human civilization suddenly stopped, and Muslims are not giving any more of such contribution? So what went well in this case? Thank you.
Okay, thank you. في طالبات حدا عنده أسئلة من الطالبات؟ حدا عنده سؤال؟ في حد؟ ما في حد؟ Okay, thank you. Go ahead. Just each one 3 minutes. Yes, start.
Okay, I'll try and run through these very quickly. You're correct in saying that the Greeks didn't adequately, or at least we are not taught how they learned from their predecessors. So I think that's a valid point. I deal with on the subject of the humanities and the Arab-Muslim contribution to the study of the humanities. I do talk about that in my book and in this talk, but we didn't have time. How to bring the lessons of this historical contribution into modern, whether it be Europe or the West or here in the Arab world. Well, as you know, educational curriculum is one of the most politically difficult and sensitive areas. I used to try and work with that, but it was so hard. I said, I'll drop dead. I'll be an old dead man before I have any success. So that's when I started writing. So it was easier for me to do it that way. So I think the media, for me, is a way to bring these messages out. Education should be doing it, but it's hard. The question about tolerance and openness, you would know better than I if this legacy is taught to young Arabs and Muslims. I don't know. I know that we're not taught it. We don't hear it. And then finally, the statement that it seems like Arabs and Muslims were making all these discoveries and then it stopped dead. Well, that's a false conclusion. It never stopped. it continued, but because Europe, through its colonial conquests and the huge amounts of money flowing in to Europe, for example, England conquering India, which transferred all of the huge wealth of India into the British Empire, the money needed to do this work went to Europe, and so it just wasn't happening as much in the Muslim countries, but it didn't stop dead. So I will stop there.
Yes. Thank you, Dr. Michael.
Well, I'll pick and choose the ones that I feel more comfortable with. The humanities, good point. I think travelers tales, Muslim travelers tales. Ibn Battuta, people like that. But to me, the crowning glory of in humanism, and it is sort of Arabic or Muslim historiography, is Ibn Khaldun's Muqaddimah. That is a fantastic piece of work, and it's a great way to introduce the Western audience to some of the most subtle sociological thinking in the Arab world around 1400, even in North Africa. Let's see, where else would I want to go? In terms of influences, it's very complicated. The mention of the Middle East, for example, and Egyptian sources of Greek knowledge, is very difficult, really. The Greeks give a lot of credit to the Egyptians for teaching them geometry, and yet Egyptian sources, as we have them, like the Orion Mathematical Papyrus, don't seem to bear that out. Greek geometry is quite different. Whether that came out of their experience with the Egyptians is a question I don't know anybody has an answer to. But here is one very important influence, and that is what we call Babylonian. The cuneiform, particularly mathematics and astronomy. And you can see the influence of that very clearly in Ptolemies' astronomical work, because he depends on various algorithms. I'll use that term, even though it's advertising. Various algorithms developed by Seleucid Babylonian astronomers to do lunisolar reconciliations. That is, to find a way to make the months and year work out all right, in the long run, by interpolation and things like that. Trigonometry, interesting point. This has nothing to do with Greece. That did come from India, but it was adopted and adapted by Muslim mathematicians, as he points out, as my colleague points out. To establish the Qibla is very complicated because it requires what's called spherical trigonometry. Because you can't just point yourself east if you're east of Mecca. You have to do a great circle, line side to Mecca to get a proper Qibla. And that's a very complicated problem. So it's true that the Muslim religion had a great deal to do. It pushed in certain directions in astronomy, inheritance patterns, for example, really fostered algebraic methods for figuring out how you partition, all of those kinds of things, compounding of interest, all of that stuff was motivated to a great extent by religion.
Thank you, Dr. Mike. Thank you. تفضلي دكتورة عائشة.
يعني أنا من خلال ما طرح تساؤل عن لماذا بهذا المعنى، يعني لماذا لا توضع أو تدرس أو تطرح إسهامات المسلمين في المناهج الدراسية مثلا، وهذا حقيقة أمر أنا أتصور يفترض أن يكون ذلك، وقبل أن يكون في الغرب يجب أن يكون في الشرق. حقيقة نحن مقصرين جدا، المسلمين مقصرين في هذه المسألة حقيقة. نحن لا نعرف عن كثير من علمائنا الموسوعيين، ومن هذا المنطلق لماذا كان أو لماذا توقفت، كما سأل أحدكم، توقفت الإسهامات حاليا؟ لماذا هذه القدرة العلمية عند علمائنا السابقين ولا توجد عندنا الآن؟ الآن لو وجد واحد متميز أو متعمق في علم واحد، في معرفة واحدة، نقول هذا عالم فقط. أصبح التخصص وأصبح التخصص الدقيق والتخصص العام وما إلى ذلك. إنما في السابق الكثير من علمائنا لو طرحنا أسماء كما طرحهم أخونا الكريم لوجدنا الكثير منهم سنسأل لماذا؟ لا أعرف. قد يكون الآن المشتتات كثيرة، قد تكون الملكات عند السابقين أكثر صفاء، أكثر قدرة، يعني ما أعرف. هناك مشكلة حقيقية في هذه المسألة. لكن إذا لم نكن على شاكلتهم فيفترض فينا كما قلتم أن ندرس إسهاماتهم، أن نستفيد من تلك الإسهامات، أن نظهرها، أن نبينها، وأن نستفيد وأن نفيد أولادنا. لأن الآن الشباب الصغير ولا يعرف شيء عن هذه الإسهامات على الإطلاق. لذلك يجب أن تدرس. والإسهامات لا نقصد بها فقط في الطب والفلك، في كل شيء، الإسهامات في كل شيء. على رأسها كما قال ابن الهيثم الأخلاق رقم 1 على رأسها. لذلك طبعا يعني أنا أؤكد أيضا، بس هناك كانت مقولة يقال بأن لا أعلم يعني صدق هذه المقولة، ولكنها يعني أن أطلق اسم ابن الهيثم على فوهة في القمر، تقع في الجانب الشرقي المرئي للقمر من الأرض، وأطلق اسم أينشتاين على الفوهة التي يعني في الجانب الغربي من القمر، الجانب المرئي من الأرض. ويقول أحمد الأستاذ الدكتور أحمد فؤاد باشا: كان في هذا إشارة ذكية إلى الموطن الأصلي لأشهر عالمين في الشرق والغرب. يعني هناك نوع من الجمع ما بين هذين العالمين والعالمين من الشرق والغرب. يعني هناك نوع من التعاون، هناك نوع من الاتفاق ما بين يعني الشرق والغرب في علم متحضر للحضارة يعني. فطبعا هذا ما أردت أن أقوله، وأنا أشكركم، أشكر الدكتور يوسف، شكرا جزيلا لك.
شكرا جزيلا. في الختام، إن لهذا المحفل قيمة ثقافية عظيمة، حيث التقينا بنخبة من أصحاب الإنجاز والإسهام لنستعرض ونسلط الضوء على حضارتنا الإسلامية وفضل علمائها فيما قدموه لجميع الأمم التي ارتقت اليوم بنهضتها وتطورها. نشكر لكم حضوركم، ولا يسعني إلا أن أشكر القائمين على معرض الدوحة الدولي السادس والعشرون للكتاب على إتاحة هذه الفرصة للالتقاء وتبادل المعرفة وإثراء الفكر والخبرات لنستفيد جميعا ويستفيد طلبتنا الذين هم جيل المستقبل. والسلام عليكم ورحمة الله.